Okay. Yeah, so I'm Cleve, and today we're going to talk about trunked radio systems, what they are, how they work, kind of at a high level, and then the last half of the talk is going to be a live demo of setting up a piece of software to record transmissions and that kind of stuff. If you want to skip that, no problem. I'm going to make it either way for the trunk recorder Discord. Um, So yeah, who am I? I'm Cleve. If you have joined the hackerspace lately in the last, I don't know, 6 7 months, I am no longer in Utah, but I used to be. I do DevSecOps for my day job. I'm a big fan of hockey. I watch a lot of hockey, and I'm super into radios, whether that's ham radio or business radio or these trunked radio systems. Something I've spent a lot of time learning about, and happy to answer any questions you might have. Now that we've talked about me, let's talk about you. I would love to have you guys in the Discord and the voice text channel. Uh, Live participation is definitely the vibe I would love to have. Ask questions. Say, hey, that didn't really make sense. Can you like show an example? Can you like explain that a little bit more? If you don't do that, I'm probably just going to railroad right through this talk. So uh, please ask questions if you have them. I'm more than happy to explain things. Just a little bit of an agenda for us. We're going to learn about just a quick refresher on radio basics. We're going to talk about conventional versus trunked radio, some different radio protocol standards. We're going to take a little bit of a look at what trunked radio systems are in Salt Lake City. And then, like I said, we're going to get that piece of software called Trunk Recorder set up and tuned with an SDR and listen to a bunch of trunked radio. So radios often get used in when synchronous communication is important. So let's say you work at a venue, you're working security. Everybody needs to hear the same thing at the same time. Let's go get that guy and kick him out because he's being a punk at the club or whatever, right? Maybe you're an airsoft. You want to have a communication that comes urgently. Maybe you're an ambulance driver or a police guy or a fire truck driver or whatever, right? Um, Different ranges of frequencies throughout the RF spectrum are allocated to different use cases. But today we're mostly going to be talking about stuff that happens in the business and the federal and the public safety bands. These are just some rough outlines of what those bands are. You can Google it and find more info. And mostly the trunked radio systems will live up here in the 700 and 800 megahertz range. Just because most of them are public safety, and that's where a lot of the public safety stuff goes. So for throughout this talk, we're going to work on this thought experiment. Let's say you're a new county in Utah. You just got formed. Maybe Utah annexed a little bit of Colorado or something. So you're a new county. You got to set up radios, right? Your police are going to need some radios. Your sewer technicians are going to need some radios. Maybe even your parks people. So there's a bunch of these different groups we have that need to communicate with just each other. And then every once in a while, maybe your police and your EMS need to talk to each other, or EMS and fire. That happens a lot. So every once in a while, you might need to be able to get both people to talk to each other, both groups. You'll need to be able to deal with terrain that's in the way that causes issues with radio reception, like mountains, which Utah seems to have a lot of. You need to have coverage in almost all of the county, and you want to build this system so it's very kind of resilient. You don't want to have it be a house of cards of technologies and issues and that kind of stuff. So building it is going to be very different than building, let's say, like a CRUD web app or that kind of thing. So the most simple radio communication is basically this. Truck A wants to talk to Truck B. So they push the push-to-talk on their radios, and they talk to each other. And they have one frequency that they use between the two of them. And this works pretty well until they aren't close to each other. Maybe you're out of range because of there's not enough power, or there's something physically obstructing the wave in the way. And so that's no good. What can we do to fix that? How can we make sure that throughout our fictional county, how can we figure out communication without having to worry about terrain and that kind of stuff? And in Utah, the answer usually seems to be, let's put a giant repeater up on the mountain. And that actually works pretty well, right? Especially in these ranges of frequencies that we're using, line of sight matters a lot more than, how much power you're using or that kind of thing. And so if you have line of sight to the mountain, or, good enough, then it'll reach. One problem with this is if your signal going into the repeater is garbled, it'll come out garbled. But, this covers most general use cases. If you've ever used a repeater for like ham radio, you've done this. This is the same thing. You're basically bouncing, your signal goes into the tower. The tower blasts it out at a higher power with a bigger antenna to the rest of the surrounding area. But with our thought experiment, right, we have a whole bunch of groups. So this means we need to maintain a whole bunch of repeaters. And that's like, that's okay. This certainly happens. This gets used a lot. But as our county grows, as more people show up, as we get more groups that want to talk to each other, we're going to start running out of frequency space. And we're also going to start running out of rack space up where we built our repeater, right? There's only so many repeaters we can fit into our 42U racks up there. And also, licensing these frequencies costs money. And then if you're using them, other people can't use them, right? Especially when it comes to public safety. And so a while ago, we actually did run out of space. And the FCC had to start this process called narrowbanding, where they said, okay, all of your signals used to be 25 kilohertz wide. Now we're going to make them 12.5 kilohertz. And at some future day, we're going to make you guys go even narrower. We need to make your systems more efficient in terms of spectrum usage so that we can fit more people in the bands, and so that so we have more space, so we're not running out of space. And so there were a couple approaches to this. There's narrow FM. Hams still use the 25 kilohertz because hams have plenty of spectrum for the amount of users that they use. But almost every business radio nowadays will use a 12.5 kilohertz FM signal. But at the same time, this narrowbanding stuff was happening. Everybody was kind of like, well, while we're improving these systems and building things better, what else can we do to kind of improve coverage? And so let's look at our fictional county again. We want to improve our coverage. Our one repeater up on the mountain kind of works, but a lot of the time it's just okay, or it doesn't reach into buildings, especially big apartment buildings. I got asked a really good question. Can repeaters share an antenna? And the answer is yes. But, actually, I'm going to pull up a picture of this for you because I think they look cool. You run out of rack space even quicker because you have to use these things called combiners, or duplexers also. And you basically it does a bunch of filtering so that the repeaters all transmitting into the same antenna don't blow each other out by being too loud, right? One thing in radio is that if you have a really loud radio next to you, it makes your radio kind of suffer from receiving quieter, farther transmissions. Yeah, these are super cool. If you go to old repeater sites and stuff, you'll see a lot of these. I think people in the industry call them cans, but big old tubes, and you can get tiny duplexers. Like I have a 20 watts UHF duplexer that's this big, really small, but for big real radio sites, we're talking about things like this. Even a ham radio repeater probably has one of these. So yeah, so the answer is yes, they can share antennas, but it's you need more equipment to do so. So yeah, how else can we improve coverage? So we can do digital radio, which is where we take our voice and encode it with a proprietary codec, um, and get it down to about 3600 to 9600 bits per second, and then send that over the air. This has a couple of really cool advantages. One, you can add in forward error correction. If you're familiar with that, basically you pack extra data in the bits, to make to help recover a garbled signal, and kind of correct errors as you go. You can also encrypt now that it's a data stream. It's a lot easier to keep people you don't want hearing your transmissions from hearing them. It also lets you identify units a lot easier. Before digital radio, there were a couple of tricks to include tones, and a certain tone would mean it was a certain person transmitting, but that can be a mess, and it's not really used outside of, I think, like New York and that kind of thing too much anymore. Most people have switched to digital radio that I'm aware of. There's a bunch of different standards for digital radio, but most of them all pretty much use this one codec because it's the standard codec for getting voice compressed into very, very, very tiny amount of bits. And it sounds terrible. It actually sounds worse than analog radio. But again, we have to comply with the narrowband stuff, and also digital radio brings a lot of cool advantages that make it worth it, as well as once you get to kind of the newer versions of some of the protocols, it sounds a little bit better. The protocols, the codecs improved over the years. It's gone from IMBE to this AMBE plus. It's all backwards compatible, but the newer versions do sound better. Let's see. Yeah, I think that about covers that. If you have questions, I'm happy to answer more in depth. These 4 protocols are pretty much what are used today. Most public safety / police stuff is going to use P25, which was this protocol developed by basically a big police organization called APCO. DMR, you've probably heard of if you're a ham. It's mostly used for businesses and that kind of thing, and it's become really cheap. The standard is open. It's not hard to build your own DMR equipment, so a lot of manufacturers have, and that stuff's kind of flooded the market both for businesses and for hams. So another way we can increase our coverage for our imaginary county is to set up a couple of repeater sites, and then do this thing called voting. And I don't know why this cursor is stuck here in the screenshot. That wasn't my cursor, it was in the video I got it from. But anyways, basically your repeaters and your radios will work together to say, okay, I'm near site 2. I'm near let's say we have a repeater on top of the city hall building as well as on top of the mountain. So you could say, I'm closer to the city hall, so I'm going to use that repeater to get into the system, because it can hear me better and I can hear it better than maybe the one on the mountain or whatever. And voting is cool. But it ends up being a little bit complicated to program into the radios and set up and make sure all the voters are working. From what I understand, the ham system, the ham radio repeater system, what is it, Intermountain Intertie, I think it is. It stretches from like Arizona to Montana. I think that's all analog voting, which is really cool, and I'm impressed that they did it, but that's so complicated. The other technique we can use that's easier is simulcast, where every site is basically synced. They have really accurate time signals, and so they blast out the same signal at the exact same time, to just kind of flood an area with radio coverage. And so you'll see a lot of sites like these, especially where there's like a big valley or a big county that you want to cover really, really well for these public safety systems. Excuse me. Okay. And simulcast is great, but again, you kind of run into the same problem where this is just like one group, right? One group to one frequency. So you need a lot of frequencies, you need a lot of sites, you need a lot of, this stuff really, it's starting to get to the point where it's kind of not going to scale super well. Once you get up to like, let's say we had our police, our EMS, our fire, we've got, public works and whoever, so this really starts to to be kind of a pain. And you might say, who would build 5 simulcast sites to cover an entire area? And the answer is Salt Lake City would. And it works really well. This is actually part of the trunk system, but I wanted to illustrate that kind of this is what simulcast looks like. You'll have a bunch of sites. They all transmit the same signal. And because of that, the radio just tunes to one frequency, and here's what it needs to hear throughout the whole valley. But again, not scalable, so what are we going to do instead? Everything we just talked about is basically what we're going to call conventional radio from now on, because trunked radio is the alternative. So again, Fire gets one channel. Earlier I used the term frequency. They're kind of interchangeable. But anyways, Fire will have their Fire channel. EMS will have a EMS channel. And the police will be channel 3, but nobody's using that right now. But the thing is, let's say you have a bunch of fire trucks needing to transmit at the same time. But let's say the fire frequency is taken up by a big fire. The other fire trucks are going to have a hard time getting in and saying, hey, I need help with this other thing, or I need this guy to bring me some water or whatever. And that channel fills up and other users have to wait. It's assigned per group. Each group gets one channel, and that's it. And so when it comes to trunked radio, you get many calls for many groups, all on the same system. And basically what happens is there's a control channel where we've added in some computers and some signaling that say, okay, we've got these pool of channels, and we're going to dynamically allocate them to the people that key up on the system and want to talk. And so Fire keys up, pushes the button on their radio. The radio says, hey, what channel's available? The system says, hey, you can be on channel 1. We're sending everybody on Fire to channel 1 right now. And it'll signal that, and so everybody, all the people who have their radio set to the Fire group, their radios will automatically switch to that frequency and listen for Fire group transmissions. The EMS will key up and it'll go to the controls channel, and the controls channel will say, hey, I have channel 2 available, you will be on channel 2, and everybody listening to the EMS group go to channel 2. And so this way you can kind of dynamically assign your pool of channels, which before was kind of fixed and much harder to work with. This means as long as not all of your talk groups are very busy, you can share this pool of channels. You have to have less sites, less frequencies, less infrastructure, at the cost of more technologically advanced systems. And this actually works really well for a lot of big, anywhere from like businesses with a couple buildings all the way up to like entire statewide systems like the Utah system, which we'll take a look at here in a second. And those are basically the end of my slides. Let's take a look at the Utah system. And we're gonna go to Radio Reference, which is my favorite favorite site for this kind of stuff. They're basically like Wikipedia for radio systems. They have a lot of information on, so like let's say we're in Utah. And we'll go look at, there should be a statewide page, but that doesn't seem to work. Really? Could have sworn there were like state pages. Let's do Salt Lake City. Okay, Salt Lake County, good enough. So when you pull up this page, it'll say there's some trunk systems here. Maybe you can find out some stuff about this stuff is old. Maybe you want to listen to the hospitals, or you want to listen to I swear there's like a bacon plant we found last time I did this. There's one in Salt Lake City. But for us right now, we're interested in the trunked radio systems, and specifically we're gonna go take a look at the Utah statewide system, which is run by the Utah Communications Authority. And this is basically a statewide agency that said, we're tired of having everybody, each county, every agency maintain their own radio system and all pay way too much for it. So we're just going to build one big statewide system. And if you're an agency that needs it, you just pay us a little bit of rent and we'll let you on the system. And we'll handle radio deployment and provisioning and working with the manufacturer and all that stuff. And so a lot of agencies like this and use it. Pretty much every police, fire, EMS agency in the state uses this, as far as I'm aware. And you can tell that because there's so many different sites where they have repeaters and networking equipment all set to network everything into this one big trunked system. The one I used to listen to was the Cache County system, so let's look at that. Cache Valley Simulcast. And so we can see that this simulcast site, they've just got 2 towers, but that covers the whole valley pretty well. And we can see that they've got these frequencies. The ones marked with C are those control channels, like I was talking about. Usually just one is the main control channel, but if they run out of space or they need to promote a second one to be a control channel to send all these extra messages, the other ones will step up and become a control channel. And so this is how we can kind of get a look at the site. And that kind of stuff. And so here's the point where I'll ask if you guys have questions, if there's things you want to know more about trunked radio. Otherwise, the rest of the talk is going to be a demo of how to set up some software to listen to this stuff. Feel free to stick around for that if you'd like, but if not, thanks for coming. It's been a blast. Ooh, that's a very good question, Yagoth. The trunked radio protocol that the UCA system uses right now is kind of old. It's called Smart Zone, Motorola Smart Zone or SmartNet, you'll see it called. They had a bunch of different names for it. And Smart Zone's funky because the signaling is digital at, I think it's like 3600 baud. But also the talk groups and the channels, the actual audio data that can be carried can actually either be analog or digital. The same signaling stuff applies. Hey, we have this frequency you can use, but the actual radios will still transmit an analog FM instead of like digital voice, which is weird and hilarious. Utah's actually one of the only states still clinging to a system like this. It is very old. It's they're getting ready to replace it, but that system keeps being delayed. I talked to a guy who works on the system at St. Con, who said the Harris, the company that got paid to work on it, is basically making a mess out of it. So that system is on its way. There's a lot of towers up and that kind of stuff. If you look in the radio reference forums or wherever Utah Scanner people hang out, there's a lot of stuff about getting excited about the new P25 system, trying to catalog all the sites and that kind of thing. Radio Reference, I think, already has a sorry, I'm having computer issues. This is a new browser I'm trying out. There should be a page for the P25 system if you want to go find it. I think it's the same thing, just Utah Communications Authority P25. I don't know why my back button doesn't work. Yeah, any questions? Any other stuff you want to know? These I should say that these listings are what are called talk groups. I should have explained that better. Talk groups are like those groups we talked about earlier, your fire group or your EMS group or whatever. I don't know a ton about the talk groups in Salt Lake, so I can't give a ton of info on that. But the ones in Cache County, at least. Okay, here we are. I can talk about a little, and this is a decent blueprint for understanding kind of which talk groups you may want to listen to or may not care about at all. Usually you'll have one or two, Radio Reference calls them law dispatch, so police, animal control, that kind of stuff. You'll have one or two of these per kind of regional area, and so that'll be your local police. A lot of the time different police agencies will share a dispatch just because dispatchers The job kind of sucks. They don't get paid a ton, and apparently it's really hard to hire dispatchers as it stands right now. Um, and so, like in my area here in Seattle, I think there's 3 or 4 agencies that share the dispatch for my local city, and then uh, there's an there's a big dispatch center that dispatches I think like 8 or 9 different agencies off three talk groups as well. But anyway, so there's cash law 1 and 2 that serve that. There's one for the jail. There's one for so that the police can talk to each other locally on the scene without tying up the dispatch frequency. There's same stuff specifically for cash sheriff. USU police dispatch has their own dispatch. And I used to live on USU campus, so I spent a lot of time listening to that. It was kind of interesting, kind of a quiet system. You don't usually see the EOC stuff key up very much. And then you'll usually have like a fire dispatch and a bunch of fire, what are called TAC channels, which are basically like stop tying up the dispatch frequency and go, while you're on scene, do all your communication on this tactical channel, and then talk to dispatch when you need to, if you need extra units or whatever. But that way, urgent stuff can happen on the dispatch channel. And so, like I said, the next part of this is we're going to set up Trunk Recorder and start ingesting some of these calls off the air. We're going to use an SDR to pull basically the SDR will listen to all those frequencies and decode the signaling, and you can put in, hey, I want to listen to these talk groups, and it'll depending on the software you use, Trunk Recorder will save recordings of that audio. And a lot of people will post this audio online to like you could Broadcastify, or there's this one, the Open Megahertz, I like a lot. It's made by the guy that made Trunk Recorder. But I did notice that the system in Salt Lake, the Salt Lake site isn't being recorded and uploaded. So hopefully we can take care of that at a space soon. I know the guy who uploads the Cache County one, he's very good about keeping it up and keeping it, resilient. So we can go in and we can see, excuse me. So like this is the Cache County group. They have the fire dispatch, the jail, the Law 1 and Law 2. I think Logan City is on Law 1, and then Cache County is on Law 2, and some other stuff like that. But again, it's been a while. It'll depend on your local stuff a little bit more. I wish I had more knowledge about the Salt Lake side of things. But there should be enough stuff online that you can put together which frequencies, which talk groups are the ones that you might be interested in listening to. So yeah, Open Megahertz is great. Broadcastify also usually has those. Those are more like live streams. The reason I like Open Megahertz is you can go back and see individual transmissions and how long they were. Some people transcribe using like Whisper, the OpenAI model. We'll try and transcribe every call and then upload a transcription as well, and then do all kinds of alerting and that kind of stuff based on, maybe they want to know when the fire truck near their house leaves.
Actually, just this individual Kelly,
and so they like transcribe and look for fire truck 16 or whatever to get dispatched. But anyways, so let's get working on Trunk Recorder. The first thing we'll do is we'll go find the GitHub.
Cache 1208.
Okay. All right. Don't need to listen to that while we do this. We'll go grab Trunk Recorder and git clone it. And we'll build it. I've done this a lot of times. I spend a lot of time in the Trunk Recorder Discord helping people out with questions and then reporting bugs I find. So if you guys run into issues or whatever, either check out the Discord or come ask me your questions. So again, more than happy to help out with this kind of stuff. And then we'll build trunk recorder. While this is building, I'm going to mention that there's a couple different SDRs you can use with trunk recorder. It supports a lot of different SDRs. The most common setup is to buy 2 of these RTL SDRs. Just the USB sticks. These are great. They're like $35. I don't want the blog, and my back button is broken. The ones I usually hear recommended come from Newelec, or they're the RTL SDR blog versions are also good. But these Newelec V5s are pretty solid. They're pretty compact. You know, $33, 2 of these and a Pi, and you should be able to listen to at least not very busy systems. Maybe the Utah system is a little too much for a Raspberry Pi. But either way, with two of these RTL SDRs, you should be able to listen to most systems, most trunked systems, unless your local system is crazy wacky. And the way to double check that for sure is there's some tools that the community has put together, and I'll pull one up here, where you basically paste in the frequencies from your system, your local site that you want to monitor. And so let's do this. I'm going to do this with my local trunked system, just as an example. So I'm near Seattle, so I'm going to pick the Seattle site, and we can go look at the details. Not really necessary, but okay, I'm in the coverage area. That should be good for me. It has the talk groups I want to listen to. So I'll take these frequencies and paste them into this website. And I'll put in my RTL SDR sample rate, which is basically the width, how wide of a signal it can all receive all at once. And so it'll say I need 2 dongles, and these are the frequencies I need to set them to. Same thing if we wanted to do let's say we want to do Salt Lake County simulcast. This will actually be good to know because that's a lot of that's a lot of frequencies. So it looks like if you wanted to do Salt Lake simulcast, you would need 5, which is wow. That's crazy. Okay. You can also use, in this case, I would actually recommend these. You can get an SDR Play SDR. These will do about 10 megahertz of bandwidth for about $125. I have the RSP2. The RSP1A is also great. And then there are clones of these on AliExpress for I think they're about $30 now. For a little while, the Space bought a whole bunch for like 11. Okay, all right, okay. The Space bought a bunch for I think $11 each. I could type. Usually they'll look. You'll see these versions. I don't like these as much, but these that have the 5 or 6 connectors on the edge. These usually work the best and have the least issues from what I've messed around with. Sometimes you'll see ones that skip out the 250 to 400. I again don't recommend those. But in most cases it doesn't matter. I don't know. These are what I recommend. Like I said, they're like $30. It's nice to have the case. It's only a couple extra dollars to have the case, and I would recommend that. This is pretty much what I use. One of these and then one of these for all my stuff. And like I said, these are great because they have the 10 megahertz bandwidth instead of the 2.4. So if we go back and put in 10, then you only need, well, wow. Then you would still need 2, I guess. Maybe one of those and an RTL SDR. But you could capture a whole bunch, and maybe you don't want to listen to the Salt Lake County simulcast. Maybe there's a site that's closer to you. I thought there was a way to... Yeah, okay. Should be a way to get these on a map to figure out which site's closest to you. And that doesn't seem to want to load. But that's okay. Anyway, so let's get my local system piecer, and let's get that set up in Trunk Recorder. So we'll copy these in. I'm using my SDR play, but I'm going to run it at a lower sample rate just because then it uses less CPU. So I put in 5. It seems like we can get away with 5 megahertz of range. This is the frequency we'll want to set the SDR to when we write our config file here in a second. Okay, Trunk Recorder built. Actually, just kidding. There's a new version that's about to come out. You probably shouldn't have to do this after about the next couple weeks, but I think it's this one. Yeah, we're actually going to build. We're actually going to build that version because it's got some improvements in it that make a big difference for my local system. So we'll wait for that to finish. Any questions? Any things you guys want to know? Do you guys feel like you're keeping up, or am I going too fast? Can you see what's on the screen? Any feedback would be appreciated. Yeah, that's okay. I didn't expect anybody to show up with an SDR or something. I just wanted to... There's not many good videos out there on the internet showing you how to do this kind of thing. You kind of have to piece together a whole bunch of different guides and a bunch of stuff to really understand what's going on. And that's something I saw a lack of in the Discord, in the Trunk Recorder Discord. And so I wanted to put a video together that was both a class for 801 Labs because of our grant. Wanted to get some better documentation out there. And also wanted to make this video for the Trunk Recorder Discord so that there's something to give to them and help show people. Oh, the other thing I'll mention, I'm not using a Raspberry Pi. Like I said, they're just a teensy bit underpowered for these things. But I am using one of these tiny SFF PCs you see that are e-wasted for about $100. The 7500T is plenty for handling up to about 8 megahertz or so from this SDR Play SDR. You could probably hook up, I don't know, 10 plus RTL SDRs. They use less CPU. And Trunk Recorder, and then that's the other reason I'm building this new Trunk Recorder branch is because it has a bunch of CPU usage enhancements. But one of these, $100 with RAM and an SSD, put Linux on it, install your SDR drivers, and you're off to the races. Okay, this finished. Let's get it installed. Okay. The next thing we're going to have to do, I'm going to start up. Oh, it was up. Okay. I thought I closed it. So the next thing we're going to do is we're going to make a config file for our local system. Close this out. So let's make a new JSON file here. not in there. There we go. So config.class JSON. We're going to go to the Open Megahertz docs. Not just kidding, the trunk recorder documentation. There's some example. I'm going to mention that there's some example configurations out there in this repository here, and I'll drop a link to that in the Discord. I've uploaded mine. These two are for the system in Cache Valley, but change the stuff to match your SDR and the control channels and whatever, and you should be good to go. I swore I had pulled up the docs before, but I guess not. But we'll pull them up. This guide is pretty good. Once you understand the stuff I talked about in the talk, you should be able to walk through this guide and kind of understand and find the stuff you're looking for when it comes to setting up trunk recorder. And then it walks through each configuration option. It's pretty well documented. It's just sometimes it can be a lot to get to, and it's not always clear exactly what you need to do. So that's why I'm making this guide. So we're gonna take this example, and we're gonna mess around with this a little bit. So we're gonna make our, just copy this, and so we're gonna say we're gonna use the Osmo SDR driver, which is what you'll use for pretty much everything, unless you have a USRP, which is, well, if you have one of those, you know who you are. And then we're gonna say we're gonna use our SDR play SDR, and I specify the serial just because I have two with different antennas for different systems. We're going to go back to that page that told us which, just like this, what frequency we want to set our SDR to. We're going to pull that in and put it, so that's our center frequency, our recommended center frequency, and so that's what we're going to put in here. I think we decided a rate of 5 megahertz was good. Yeah. This error is an adjustment value for, like, when you get your SDR going, it might be a little bit off in terms of frequency. You can use this to adjust it, and I'll show that in a little bit. It's a pretty easy tweak. I think gain, what did I have it before? 30. And a lot of the stuff you'll kind of build your config and set it up, and then as you run it for a day or two, you'll kind of get a better feel for what you want to tweak, what needs to change. This one we don't need to specify the antenna. Oh wait, yes I do actually. Just kidding. Oh well, I don't have to, but I'm going to. I think it's ant-A. Let's double check that. Probe. There we go. Antenna A. Digital recorders is I'm probably not explaining this well, but how many threads, sort of, you're going to want to have to, how many, I'll explain this later, but basically we're going to want roughly one for each frequency we have. This one says we need 8 recorders. The web tool should tell you, so that helps. Basically, it's how many threads you want sitting around waiting for transmissions to come in and handling them. I'm not sure if they're actually threads, but anyways, they're called recorders. But because my system is funky, we're gonna put a bunch in. Then we're gonna go look at our now we're gonna tell it about our system, our trunked system. So the first thing it needs is where are the control channels. It can figure out the rest of the frequencies from the control channels. The control channels will say, hey, go to frequency XYZ, right? It's the same thing as tone, the radios. But you need to tell it where to look for the control channel. So in my case, I have 4. So I'm going to put those here in this list. the difference in formatting can be a little tricky, but you basically want 3 groups of 3, or you want it to be 9 long. This is 851 megahertz, 0.8875. I had the hardest time with that when I started doing this. There are also, I should also mention, there's tools out there that will automatically generate you a trunk recorder config to start with. If you pay for Radio Reference Premium, I think it's like $30 a year or something like that. That can be nice to have. So it's a P25 system. We're not going to worry about unit tags, but talk groups. We want to tell it which talk groups we care about. And if we have a limited amount of processing power, we may want to say only record these certain talk groups, or only, if this talk group comes on, drop a recorder and move it over here because this one has a higher priority. So let's call this class talkgroups.csv. Radio reference, again, if you pay for their premium, you can download all of the talk groups as a CSV, which is really nice. If you don't have premium and you want a CSV, hit me up. I don't mind sharing a little bit with you. So let's grab the talk groups. Oh, I gotta log in. Hold on. Don't steal my info. Where were we? This. Okay. Okay, so we'll download our talk groups. And I'm just going to download all of them. And since this is the same as the ones I already use, I'm just making another piece in config. Basically, I'm just going to make a copy of these and we'll rename it to class talk groups. But it's just a CSV of the ID of the talk group, whether it's a digital, like for SmartNet, the ones in the system in Salt Lake. Do I not have those? I may not have those. Oh, here they are. Yeah, so it'll say if it's analog or digital. Almost everything on the UTO system's analog. A short title for the talk group and a longer name. The short title comes out of where you're using like physical handheld scanners that do these, and there's not a lot of space on the screen. Actually, let me pull up a picture of those. Those are nice. And I crashed ARC. This is what I get for beta testing. So something like this, like a physical scanner, a police scanner that listens to these trunked radio systems, they don't have a lot of screen space, so they'll have a smaller talk group name and that kind of thing. Anyway, so we've got our CSV of talk groups. We'll hook that into our configuration. We'll leave squelch where it is. This is fine. So let's see if we can get this config running. So we're going to run trunk recorder and say that the config is the class one. It's going to start up and it says unable to find a source, which means it doesn't like my SDR. Huh. Oh, it's because there's a dot in here instead of it being in the format it expects. Okay, let's try that again. Okay, so these are errors saying it's having a hard time finding the control channel. Sometimes it checks the first 3 that you put. it starts at the first one and checks that one, and starts at the second one and checks that one. Like I said earlier, if those aren't the main control channel, if those are ones that get promoted to control channels later, that kind of thing, you might just have to wait at startup for it to start working. But now we can see that it's working. I'm gonna shrink it down a little bit. We can see that this is our first system we've configured, that this is the 21st call, or the whatever number of call. It's this talk group that's being used, and at this frequency. And so basically all it's doing is it's recording these calls, and we've done it. We've basically set it up. We'll see that our error value, there's, okay, let me stop it so I can actually point at some stuff. Here we have like hertz error, like I was talking about earlier. Sometimes your SDR will have a small amount of error in the frequency it's set to. You'll see that mine usually hovers about -500. So if we go back and edit the config and set our error to 500 to counteract the -500 here, you'll see my error kind of will sit more around 20 to 100. So it works out pretty well. I'm also going to copy over this part of the config that makes the printout a little prettier. It'll show you the names of the talk groups and the console, or at least it should. So let's try that, and we'll see it check all the control channels here. And we got it. Yeah, so we can see that we're hearing the Norcom police, and we're seeing the local transit system, the train control talk group. These are less fun to listen to than I thought maybe they would be for all the light rail and that kind of stuff. Lots of police, lots of fire. I took my I took my system down today, and there was a big crash on the road behind us. I was kind of sad that I didn't get to listen to the topic from that, the traffic from that, but that's okay. Yeah, so this is it. We've pretty much set it up. You can tweak some stuff. Maybe you run into an issue, or your calls are too short, or they're not recording properly, or that kind of stuff. Come to the Discord, come ask questions, and we're more than happy to help you troubleshoot your config. Setting up your config can be quite tricky. I noticed I actually messed up here. I talked so much about you want to have your frequencies in the right format, right? You want to have 9 numbers when you're describing your frequency. And so this one I left off as 0, it looks like. But yeah, that's pretty much putting together the configuration and doing that. Now that we've run it and recorded some calls, we can go in here and see each call gives us a JSON file that talks about this is when this thing started. Did someone push the emergency button on their radio? What talk group did they talk to? During this recorded call, which different IDs keyed up on the system? What frequency were they on? That kind of thing. And then there's also an audio recording, but we don't really need to listen to it, and they sound terrible anyways. Yagoth asks, the install guide for Linux is a separate setup for HackRF. Is it weird, or is each SDR going to have a bunch of prerequisites? Yeah, so basically each SDR, yeah, it's complicated. Each piece of software implements everything just slightly differently, and so like the support for each SDR can be tricky. There's a piece of software called SOAPy SDR that tries to make like an abstraction layer that works, but not everybody includes support for SOAPy, or sometimes the SOAPy support is... Okay, what's going on here? Sometimes the SOAPy support is not great. But you'll notice that I have in my config, I'm using SOAPy SDR. Trunk Recorder does work with SOAPy SDR. So I'm using SOAPy SDR as my quote-unquote device, and then SOAPy goes and does the device-specific stuff for SDR play. The RTL SDRs are usually what is recommended just because they're the easiest to get set up. They're very plug-and-play. There's a ton of guides for those online. HackRF, I think, has built-in support in Trunk Recorder. Install Linux. Yeah, you just need to make sure that you install the driver and the library for your specific SDR. It's not that anything will break or be different. It's just that if you want to, the driver for your SDR may not be built into the GNU Radio library that Trunk Recorder uses. Yeah, GNU Radio Osmo SDRs. It implements support for a lot of SDRs, and I believe they've actually just finally added SDR play devices as well. I haven't messed with it. I need to. But it supports a bunch of SDRs, but you'll notice that the HackRF isn't on here. They have a separate library. Or if they, okay, so they do support the HackRF, but you need to also have libHackRF installed. So yeah, this is kind of the problem with SDRs. The support for each device is kind of hard, and so for a lot of the stuff, if you want to mess with SDRs, I would recommend either get an RTL SDR because they work with everything, or have a use case in mind with software and then look at that software and see what it supports and then buy your SDR. Or hope and pray that it uses SOAPy SDR. But yeah, that's pretty much it. We recorded some calls. We got some JSON stuff. We got some audio that we can listen to later if we want. Once I get my stuff put back together after taking it apart for this class, I'll post a link to my web UI. There's a cool web UI out there called RDO Scanner, and it makes a nice little web UI that you can host with a. I thought there was a demo here somewhere. Nice little web UI that you can host that looks like one of those physical scanners. And you can go back and listen to old calls. Or you can set up a live stream and select the talk groups that you want to listen to. I usually do not listen to all of them. I usually listen to like Redmond and Norcom, and you can go through and enable them and whatever. But it makes a nice little web UI. They have an iOS app and an Android app as well. So you can listen to that. You can, in Trunk Recorder, you can upload straight to Open Megahertz. If you want to contribute to letting other people be able to listen, like I said, Salt Lake is missing. The hackerspace is hopefully going to work on setting up some SDRs and recording and uploading to Open Megahertz. But the Cache County is covered, and then a lot of the system is recorded up in Weber County by Wi-Fi Luke. He's been working on getting this set up. But yeah, other states have a lot of good coverage. That's pretty much all I have. Again, happy to stick around and answer questions or help you set up something for your own local system, but I think that's pretty much what I have to share. Thanks for coming, guys. Really appreciate it. This class was made possible both by 801 Labs and also the ARDC, who was very kind enough to give us a grant to do a bunch of cool radio stuff. And part of the stipulation of that grant is making these classes public and open and help and contribute back to the community. So huge thanks to them, and yeah, thanks for coming.